Okay, 10.2d, asymptotes. What are asymptotes? Simply put, okay, it's not in the, what I'm going to say is just in words, simply put, not in the notes. An asymptote is simply a line whereby the curve tends towards, okay, without. I say again, asymptote simply put, very layman language, it's just a line whereby the curve tends towards closer and closer without touching. Human behavior? Yes, it's human behavior. I'm just saying in a very layman way, okay? It's not a mathematical definition. And the mathematical definition is here. Okay? Later I'll go on to it. Alright? What is a horizontal asymptote? I use example. I don't want to go to the terminology. I use example to demonstrate. Okay. Determine the horizontal asymptote of 2x minus 1 over x plus 3. First, what do we do? Okay. In order for us to carry on, we must do a long division. How do we do a long division? You do it better than me. Alright, long division, we get 2x plus 6, and then what do I get? Negative 7. What can we interpret from this? What is the quotient? The quotient is 2, so therefore result must be 2. What is the remainder? Remainder is negative 7, therefore it's minus 7 over x plus 3. I like this form because it tells us a bit more. What do we mean? What do I mean? As x tends to infinity, this whole thing tends to 0. Get it or don't get it? Because the denominator becomes very big. This whole thing tends to 0, which means the y tend towards 2. Follow? Behaves like y equals to 2. Okay, maybe without a sketch you may not quite get what I mean. Never mind, let's use a sketch here. Okay? 2x minus 1 over x plus 3. All we are saying here is now, okay, you sketch. As x becomes very, very big, you realize that it almost behaves like a straight line. And this end as well, if you zoom in a little bit more, or if you zoom out a bit more to see this section, it almost behaves like a vertical line. Y equals 2. That's all we are saying. All understand? Okay? So, So, y equals to 2 is therefore a horizontal asymptote because as x tends to infinity, y behaves like y equals to 2. So, vertical asymptote. Exactly the same equation. Now what happens here? You look here. Ignore the words for now. Let's look at this expression here, this part. Can we say as x tends to negative 3? Look here, as x tends to negative 3, what happens to the y? Look here. That means your denominator becomes 0. That means your y tends to infinity. Tend to infinity means what? Means this, right? I show you. Yeah. This one. That means as x tends closer and closer to negative 3 somewhere here, y goes very high up. or very far down. So it almost behaves like a straight line at near x equals to negative 3. Get it or don't get it? Correct? So therefore, the line x equals to negative 3 is what we call a vertical asymptote. To put it very crudely, you want to memorize, you can memorize this line. But does it must make sense to you. Because as x tends to negative 3, the denominator goes to 0, the whole thing tends to infinity, therefore it whole is a vector. You want to memorize, of course you can without understanding. Anybody can memorize without understanding. I just let this be 0. Correct? Let x plus 3 equal to 0. That x to negative is a vector. You want to memorize, you can. Should you? Follow? Okay, can? Okay. This I showed you just now, my GC sketch. This is the part that I caution all of us at the start of the chapter. The GC can only help us this much. I repeat, the GC can only help us this much. I showed you the GC sketch earlier, and it's exactly this. Are you going to sketch this on your screen? Then you are no different from photocopier. Alright? You just photocopy what you see on the GC. Do you know what I'm saying? So we cannot do that. We are supposed to know that actually as x tends to infinity, y tends to 2. As x tends to negative 3, y tends to infinity. So we should then indicate the asymptotes in dotted line and label them. I repeat, you should sketch your asymptotes in dotted line and label them. I say again, the GC will not give you these dotted lines. You have to get them by analysis. All okay so far?